A little bit of this might be review if you've already taken computer science, but I didn't want to assume that, and you can always use in practice. So, you may or may not remember number systems. Anybody know what binary is? This is just sort of general computer science, but yes.
Ones and zeros.
Yeah, so it's based on what number?
1.
2.
Oh, like 2. Like
Yeah, sorry.
I was like, wait, what?
And then octal is based on 8. Alright, decimal is based on 10. Okay, has anyone not learned this already? So I don't want to like, okay, cool. We're just going to do review then. Hexadecimal based on 16.
That's a common.
Yes. Okay, and so this was just walking you through how to do it, but everybody is actually fine. I'm not going through this. Okay? I'm suspicious one of you is fine.
Which one?
That's the question. Trying to look like spot fear in someone's eyes. No, binary.
Exactly.
Okay, so
I know.
Okay.
I know what I know.
Alright, so these you should be able to do somewhat in your head. So just shout it out when you have the answer. So hexadecimal.
Oh man, it's
1, 1, 11.
I don't remember the letters.
I don't remember how to convert stuff.
Back up 3 slides.
We literally did that at the very end of this area.
Okay, here we go.
It's 10.
That's something.
Alright, wait, Ria's got it, so we'll be fine. So hexadecimal is 0, it goes all the way up to 16, and so the way you handle that is you start with letters. And so A is 10, and then F is 15.
I remember that.
Okay. So we're gonna try this again, and if we need to, we can go back a little ways. And then
Yeah. Oh, this is a tough one. This is a tough one.
Oh,
7?
There's no 7 binary.
Yeah,
Oh, that guys solve the binary.
Solve for the thing that's not there, right?
Oh, 1.
and if you have enough people that have
3
it,
ones.
okay, it's 3 ones in a row. Does anyone need an explanation of why that is? Okay, Jake, do you want to explain?
I really don't.
You don't want to explain?
No.
Okay.
A lot of convergence.
Someone else want to explain, or should I do it?
Okay, I got it.
Alright, go.
Oh, sorry.
Okay, so it also helps
It makes
visually.
me feel really good. I forgot it.
Happy birthday, Lewis!
Lewis! Happy birthday!
Happy birthday, Lewis!
Is that right? What?
Is it your birthday, Lewis?
Thank you.
Moving on, so, sorry. For binary, or for any number system, you have one like location for each quote-unquote digit. So in the 10 system, it's not ever really written this way, but this is actually what you have as a multiplier under each digit, which is 1, 10, 100. And so for 1, 1, 1, this is 1, 2, 3, 4. So you just add these together. It just helps visually. Okay. Okay, so we're not going to do any big numbers, but the idea is to be able to do a couple of these in your head, because we'll use them later. So what is this one then?
7.
Yes, it's 7 again. For questions, I'm sorry. Because if the number is below whatever number something is based on, it's going to be the same. So octal can have digits 0 to 7. So does that make sense, everybody?
Oh, yeah, okay.
Okay. This one is a tiny bit harder.
Wait, so B is 11, right?
Yes.
Okay.
Just give it away.
110 and 111 looking at decimal. No, we're 116 and 111.
What?
Right?
Okay.
Wow.
So, this is one you guys have enough.
27?
Yes.
Alright.
Okay. This,
I'm sorry about what I was saying.
yeah. Does that make sense to everybody?
Oh,
So what she's doing is 16 to 0, 16 to 1, and then we just have 1 and B. And so since this is 11, 11 times 1 plus 1 times 16. Does that make sense? Yes. I don't believe you. Okay, so So
Is
this,
that the ASCII value?
No, we're not talking
No,
ASCII yet. No.
it's just because A maps to 10, B maps to 11, just because there isn't a single digit for numbers above
Now I get it.
10.
I was like, that's not
We
the
learned
ASCII
this
value.
Yeah,
You're
no.
not paying attention.
We had a
So,
whole test.
What?
We had a whole test on this in comp sci.
Yeah. No, I did horrible.
How do you
anyway,
feel about
let's
that?
not talk about the comp sci program here. Moving on. You guys got it, right? Yes.
Sure.
Alright, another one here?
1000.
That's
No, it's actually just that I'm a horrible person.
Oh.
You can't have 8 in octals because it goes from 0 to 7.
Oh, yeah.
Oh, octals the 8, oh, 16.
That's not right.
Okay.
Okay, so that's,
Isn't there like a
You were
special
right,
way to
decimal.
convert these
Yeah.
Yeah.
in your head easily? That
There
may or may
is.
not be what I'm leading up to on exactly the next slide. So hold that up.
okay, because I don't remember it.
Oh,
So I have
Yeah.
to convert to decimal and convert it back.
15.
Yeah.
Oh,
Okay.
Hexadecimal, right?
So we'll do it over here this time.
It's a bit like light up.
So if you just
All
add
that jazz.
another one here and then add across, does that make sense?
Yes.
So you have 12, 14, 15.
Oh, it's hexadecimal.
15, and then that is F. Does that make sense to everybody?
Yeah.
Okay. So, what Emma was going for, sort of, is that if you notice on this last slide, do you see anything interesting about how we have 3 binary digits mapping to the highest possible octal value, and then 4 binary digits mapping to the highest possible hexadecimal value?
Yeah, that's pointed out.
Yes, well, that was not an accident. So if you look here, these first 3 digits allow you to make any digit between 0 and 7, right? Because we just proved, so 0, 0, 0 is 0. So that means, and then we just proved that 3 ones is a 7. And so just trust me, you can get everything in between. We don't have time to demonstrate every single one. But what does it mean if you can have digits 0 to 7? What number system has digits 0 to 7?
That's
So,
the first digit.
That means you can have 3 binary digits to represent 1 octal digit. Does that make sense to everybody? Okay, so then what is 4 binary digits?
Hexadecimal.
Yeah. So we just proved it was 0 to 15. That's the possible range for hexadecimal digits. Theoretically, you could go on, but there's no reason to. These are the common ones you use. And that will become really important at the very end if we get there. So that's why I'm going to continue talking fast so we do get there. So the first reason why we should taught this is because we're going to go into a little bit of styling and how to make pretty colors on your website, because that's very important. And so that begs the question, how do you make colors out of numbers? Does anyone know how does you do this?
I forgot it, I guess.
I don't think that counts. If you can, unless you can tell me you don't.
That hexadecimal, like F, like 2F and 2B, like, they all relate to a color, like, palette in a way. And
Sort of, yes. Good.
Good job.
They do. Okay,
Yeah.
so you use 2 hexadecimal digits to represent each part of the RGB value. Anybody know what RGB stands for?
Red, red, green, blue.
All right. And they're the additive primary colors. I had a slide on color theory. I'm sorry, if you want to look at my PowerPoint online, you can. Trust me, they're the primary colors. And so, for example, you have 2 at the beginning represent red, the ones in the middle are green, and the ones at the end are blue. Generally, you're not going to have to change it by hand. There's all sorts of online things where you just plug it in and it actually visually shows you the number. But people will laugh at you if you can't represent some of the basic colors just off the top of your head. So that's what we're going to practice. Because we don't want you being laughed at.
Red.
No.
Any random guesses at what this one might have to be?
Okay, so now.
It's okay, Isaac was really excited. I don't know.
It's a really red color.
You got it.
Yeah, so it's this fuchsia thing. Moving on.
I figured it out.
Okay, so what does this represent?
Black.
White.
Black.
Or somebody pick a side and tell me why.
Black.
Black.
So it won't move from the center. What?
Yeah.
It is black.
Yeah.
Black because white is a different thing? Is that confusing?
I know what white is, so that's why.
So when you think about it, with a pixel you have three kind of
He's cheating for the record.
tiny light things. So if the value, so those values kind of represent the brightness of each light inside the pixel. So if it's all 0, then the pixel isn't lit up at all, and there's no current going to it, so it's going to be black.
Oh, that works.
That was a good explanation.
That's because that's the explanation I told him when I talked to him.
Yes.
Actually, I knew that
You
from.
retained it, and that's all that matters.
Can
Anybody else?
I give a good mnemonic for that?
Sure.
If you look at that, 0, nothing, black is the absence of color. So it's an easy way to remember that that's black.
Yellow pixel. Block yellow.
There you go. And it's a little easier if you go into the color theory of it and whatnot, but this is just to get you kind of awake. We have to give me. What about this one?
A little less.
A little bit more.
More yellow.
Orange.
More yellow than green.
Well, think about it. So A5 is less than or greater than
Blood orange.
Less than.
Oh,
So if it's yellow plus green, what is it?
yellow.
Blue. You lied to me, yes.
If you go up in the rainbow, then it is orange.
I was right.
I wasn't sure about it.
I was just trying to be snarky.
What about this one?
Okay,
White.
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 Alright, white.
Yeah.
Okay. And the last one?
Purple.
Yeah.
Okay. Well, I mean, I did all the ones that aren't red, green, or blue, so you also could have gone from there. So one really quick thing to note is you can do custom colors using this. And so I swear these are exactly these hex codes because I went into the custom color palette, converted it from hexadecimal to decimal using skills I clearly just learned on the previous slide. And that's how I made these. So it's useful. I also have the same exact colors for every single Chap Research slide, like stored the hex codes for the colors, and I convert them into Word every time. So it's useful. Alright, so when you use it for something called CSS. Does anybody know what that is?
Pretty color.
Yes, pretty colors. Blake?
That's
What
the
is-
inside of these.
Yeah. That's really slow. But, so using cascading style sheets, there are 3 different ways of adding styling to web pages. So there's inline, internal, and external, which we'll cover a couple slides later, so calm down. So the reason is really, the question is really, why would you do something like this? And so that's because it used to be that you had to do styling within your HTML. And so once you had all the content done, all the styling done, if you ever wanted to go back and change the color of like every piece of text in the entire web page, you had to change it in every single HTML tag, and it was a pain. So CSS is a way to separate the styling from the content of HTML. If that makes sense. Alright, so inline styling is something you do within the tag, and so then that means it only affects the tag is written within. So if you guys remember attributes from HTML yesterday, it's just setting something about the tag. In this case, it's a style, and then within the double quotes, you actually write CSS, which is sort of its own language with its own syntax. And then to talk about the syntax, you have at the beginning what's called a selector. And so that'll either be the tag name, like you see here. It can also be the ID or the class, which we didn't really talk about, but I have on the slide from here. And then you just have a series of declarations. So it'll have a property, and then it'll tell you what the value of that property is going to be. Does that make sense? Anybody know what else you can do besides colors and font size? Yeah? Yeah. So you can do anything visual with CSS, and you can look up more examples of that with W3. Okay, so classes, the only real difference you have to worry about is that classes are something that further defines your tag, but can apply to multiple different tags. So for example, in the Sprocker webpage, I have the form there, so the table I declared as class form, so that in the CSS I could make it so that every single form had a table without borders. And so there are a whole bunch of tables that all have that same class, and that makes it easy for me to have them the same style across the entire webpage. the difference then is that IDs are used to give a single element a style, and so each tag has to have a different ID if it has one at all. And so that's like the first name field is an ID. And then the other type that we commonly use is what's called internal styling, and it goes in the head of the HTML document. Anybody remember what the other part of the HTML document is?
Body.
And so it'll affect the entire HTML document because it's done at the top. And so you still use the style tags, but you have kind of more expanded CSS. Again, you have the same parts. I'm going to keep quizzing you unless you guys ask questions, just as a heads up. So if you have to make up questions, go ahead. But can anyone tell me what this is called in terms of the syntax of a CSS statement?
Color.
Doing.
It's a declaration, but I guess a better question is, why is there a period here? What does that refer to, ID or class?
ID.
Is anyone taking notes?
I don't know, I wasn't here yesterday.
It was today.
Oh, I do have pencils. There we go, a question.
Oh, it is a class. Dang.
Class, okay.
Okay.
Write that down.
You have this stuff to refer back to because you're going to have to do it in a second.
Oh, then I need to write that down.
As soon as I ask
Already
questions,
have
suddenly you're
pencils.
like, wait a minute. Anyone need paper before we move on?
I need to.
I promise I'll make you guys do this in a second.
Rowan needs everything. I do, Tim.
Okay. And does everybody have note sheets and stuff from yesterday? Does anyone want any more?
Actually, Benjamin might need a couple.
Okay. You want to come get those?
Yeah.
They're in those two folders. So just take them off to the side.
Okay, Alice.
Okay, Rachel? Yeah?
Each one that has like a dot dot in the middle is called a declaration, each separate thing,
So yeah, so this is a declaration.
and they both have two parts.
Yeah.
Okay.
See this mousing thing?
That was pretty intense.
Okay. And then, which one's your internal styling? Any questions on this? Alright, and so then the other important question is what happens if someone declares something in the head that's different than what's in the tag itself? Any questions on who wins?
One higher up.
Got paper?
The tag itself. So
Um,
cascading, the word cascading in cascading style sheets refers to the fact that there's different layers of rules. And so, as I said, external, internal, and then inline, going from kind of most broad to most specific. And so, most specific always wins, whichever level you're in. So,
And then exception.
Alright, so your turn to pull the laptops. Go to your web pages. Hopefully you remember how to get into Putty, how to log in, and how to navigate the web page you're working on yourself.